Good afternoon and welcome to this session in the Shape Your Future series, where we are exploring the STEM career journeys of Australia's rising stars. Today we'll be hearing from Dr. Sharyn Fitzgerald, and I'm Dr. Mateus, and I'm a program advisor at CSIRO, the Australia's National Science Agency, and I'm also part of the Catalyst program at the Academy of Technology and Engineering at SEA. As we gather from Australia, I would like to first to acknowledge the traditional custodians of the lands from which we meet. I'm joining you today from Orangery Land. I pay respect to the elders, past and present, and to any Aboriginal and Torres Strait Islander people who join us online today. As we share and discuss our own knowledge and practices, we acknowledge the deep knowledge forever embedded in custodianship of country. Before we get into this session, you would have seen that this session is being recorded. These and all talks in this series will be available in the STELR YouTube channel for you to watch anytime. There is also a Q&A button in the bottom of the screen. If you have any questions, drop them in there and we will get to them in the discussion at the end. There is also a chat function, but any questions should be dropped in the Q&A session. Finally, you will be sent a feedback form after this session to the email you registered with. Please let us know what went well and what you might like to see in our series next year too. Now I would like to introduce you to Dr. Sharyn Fitzgerald to tell us how she came to be working on healthy lifestyles and disease prevention. Many thanks for joining us today, Sharyn.
Thank you so much, Mateus. I'll just share my screen here now, make sure I'm doing the right one. Lovely. So is this okay, Mateus? The screen? Lovely.
Yes.
My name is Dr. Sharyn Fitzgerald. I work as a senior research fellow on the Aspirin XT clinical trial through the Department of Epidemiology and Preventive Medicine at Monash University. And I would like to say there seem to be some themes that I circle around throughout my career, and I guess I start with talking about headaches and end with talking about headaches. So I guess that's where we'll go forward. And thank you for the invitation as well. Okay. Right. Lovely. So I would like to lead with that the pathway to career starts early. And in my case, I can pinpoint where my career started from way back to when I did high school work experience. And I actually went to the Royal Melbourne Hospital and I worked in the renal laboratory there, just observing. And one of the things I actually did see sitting in a bench on the lab was a horseshoe-shaped kidney. So I just thought this might represent my experience of work experience through the Royal Melbourne Hospital. And this is just to show you what a horseshoe kidney is. It is a common abnormality of the urinary system, and it does affect about 1 in 4 to 800 newborns and usually causes no major signs or symptoms and often does go undetected for many years. But this is my sort of focal pathology lesson, and really it stirred my interest in science and research. So from that point in time, I went on to commence a Bachelor of Science, again, through Monash University. I commenced in 1990, and then at the end of 1991, I had the opportunity to apply for a summer vacation scholarship. So it was a short-term research position. This particular one was advertised through the Baker Medical Research Institute. And ironically enough, my work experience played a key role in what I was offered for this summer vacation scholarship. So the team at the Baker were supplied with numerous 20, 50 CVs of students who were interested in working there. And because I had worked in a renal laboratory during high school, the renal laboratory at the Institute offered me a 6-week scholarship position. And during that time, I was just looking at and engaged with a research program where they were looking at the role of medulipin, which is a renal hormone, and its influence on blood pressure control. And I just have a quick little diagram here, which shows different kidney zones, and the outer edge of a kidney is the cortex. The inner next layer is called the outer medulla, and the inner medulla, the IM, is actually which produces the region of the kidney that produces medulipin. And my first little segue to my career pathway is that medulipin itself was first discovered by Erik Myrhood and Bjorn Folkhoff, who at that time, and still is, was based in Göteborg, Sweden. So I continued on with my Bachelor of Science at Monash University and completed in 1992 and majored in physiology. And physiology is the study of how living organisms function, and these include processes of nutrition, movement, and reproduction. Interestingly enough, the Nobel Prize in Physiology in 2005 was actually awarded to two Australian researchers for the discovery of the bacterium Helicobacter pylori and its role in gastritis and peptic ulcer disease. So that was a big boon for Australia and for Australian researchers. My other major was in pharmacology, and pharmacology is the study of drugs, especially of the way in which they react biologically at sites within the body. So continuing on from my bachelor's degree, I completed an honours degree program, which is an intensive one-year research program. This was undertaken through the Department of Pharmacology, again at Monash University, but I actually did it off campus, and this is where my first connection happens. I actually did my honours degree program at the Baker Medical Research Institute, where I did my summer vacation scholarship. So it was that building of networks and relationship building over time that led me to take this role at the Baker Medical. And during this year, my honours year, I completed a thesis looking at nitric oxide synthase blockade and renal vascular responses to norepinephrine and endothelin. So these are some natural products circulating in the body and just how they impact blood vessel control and other systems within the body. And we did identify that specifically in the kidney, nitric oxide reduces the impact of norepinephrine, but not endothelin. And of course, nitric oxide is a vasodilator. It's the primary means of action of nitric oxide, whilst norepinephrine and endothelin are vasoconstrictors. So during this time, you can see here in the corner, I published my first scientific work on the results of my honours year. And I continued on with the research program and continued on to do my PhD. So I moved fields slightly and undertook a PhD with the Department of Physiology at Monash University. I kept the same supervisor, Professor Anderson, and took on an additional support supervisor with Professor Evans. And this time I was examining still the kidney and still blood pressure control, but looking at a different kind of system, angiotensins, which are vasoconstrictors, and their contribution to blood pressure control. Angiotensins themselves are very important and the building block for some of the very important blood pressure control agents we currently have, called angiotensin II receptor antagonists or ACE inhibitors, which are currently used for reducing hypertension in the population. So the pathway traditionally for doing a PhD, if you're interested in continuing on to research, is to do a postdoctorate. And here is where an opportunity arises, or did when I was there, to actually undertake this program of research overseas. So I took my first postdoctoral position with the Department of Physiology and Biophysics, which is based at the University of Mississippi Medical Center in Jackson, Mississippi, in the far south in the US. And interestingly, a few key items about this department and this university, that in 1956, the head of the department of physiology and biophysics, Dr. Arthur Guyton, actually wrote the first edition of a textbook of medical physiology. The picture here is of actually the 10th edition, and Dr. Guyton was still working in the department some 43 years later, still researching and still writing publications. So he was a very inspiring man. Also, this university was responsible in 1963 for undertaking the world's first human lung transplant, and a year later performed the world's first heart transplant surgery at this location. So this was a really well-respected department, research department, and a really great place to be. So I was there for 3 years between 1998 and 2000. And during that time, I also continued to look at nitric oxide, a vasodilator, and in this instance, looked at the role of nitric oxide in reducing the onset of high blood pressure when someone has diabetes or under diabetic conditions. And so here, just a quick picture of the University of Mississippi Medical Center in the capital of Mississippi, in Jackson, and some of my lab and lab colleagues there. So here's, I guess, my next swing about connections. In 1998, Lou Ignarro was awarded a Nobel Prize in Physiology for discoveries concerning nitric oxide as a signaling molecule in the cardiovascular system. And so this is a picture of Lou Ignarro when he came to visit our department. And the function of nitric oxide is the active ingredient of Viagra, if anyone is interested. So I was in the very fortunate position that when I completed my postdoctoral 3 years in the US, I had an opportunity to undertake a second postdoctoral period, another period of research for 2 years in Sweden. And this took place in the Department of Physiology. And here is my next connection, that the former head of this department was actually Bjorn Folkov. So the first person who identified medullipin, which was when I did a summer vacation scholarship some 10 years earlier, is from this group. And in this setting, I looked at a range of different mouse models of both obesity and diabetes and of prenatal programming. So that is influences of the physiology during pregnancy and the outcome on the babies. And using this, looked at investigating their effect of changing these factors on cardiovascular disease. So I completed 2 years of research program in Sweden and was fortunate to come back to Australia and undertake, at this point now, undertook my own research program, and I returned back to the Department of Physiology. And I looked at, continuing to look at nitric oxide, but some of the systems responsible directly for producing nitric oxide, and this is the endothelial nitric oxide synthase system, and its control in arterial blood pressure, its role in controlling it during the early stages of diabetes. And so these are just some little demonstrations of some of the things I examined, and looking at blood pressure control and heart rate in some mouse models. If you just interestingly, average heart rate for a mouse is around 500 beats per minute. Around this time, I had decided that I wanted to undertake more clinical research instead of lab-based research. And I had the opportunity to undertake a research program linked with the Population Health Research Unit, again, now back at the Baker Heart Research Institute. So where I did my medullipin research many years earlier, I came back and was undertaking some clinical research. And one of the particular studies I was involved in when I came to the Baker was in rural India. And we were looking at a model for understanding the development of vascular disease in these disadvantaged communities, and to determine the level of contribution of risk factors for developing vascular disease in these communities. And I just had a little visual of this is where the Baker is here in downtown Melbourne, but this is just some local villages in the region that we were studying, and cooking up some dinner on the roof of their property. Also, what you can see here is these are looking at one of the risk factors And in this particular instance for stroke is just age. So you can see that with increasing age for both men and women, there's an increased risk of stroke as we get older. So that is one of the risk factors for developing vascular disease, but of course it's not a modifiable risk factor. It's something that we have to work with and try and improve where we can. So this leads to currently where I am now. So in 2010, I joined the Aspirin study as a senior endpoint manager and with the Department of Epidemiology and Preventive Medicine, and came back to Monash University. And so the clinical trial I'm involved in is called Aspirin in Reducing Events in the Elderly, and it's currently in its extension phase, which I'll go on and describe. So I thought I'd take the time now to have discussion about the Aspirin study and what it is and what we've learned so far. So the Aspirin study began its life as a primary prevention trial of healthy older people, and we define healthy by our participants when they started the journey with Aspirin that they had not previously had heart attacks or strokes or dementia or a permanent physical disability. And because this was a clinical trial, there's the best way to run a clinical trial, gold standard, is a randomized, so 50-50, double-blinded, placebo-controlled clinical trial. And so that is half the population in the study were on aspirin and half were allocated placebo, and that was randomly allocated. And the participants actually didn't know what medication they were on, and nor did their GPs, and nor did the researchers. And so placebo-controlled meant that we could compare the outcomes that occurred in the people who were on the aspirin side versus the people on the placebo side. So this study was one of the largest of its kind in Australia ever undertaken in a healthy population group. And we had a total of 19,114 participants enrolled in this study. Of those, 16,703 were based in Australia, and this was an international study, and that's on the basis of our funding was predominantly provided by the US government. And therefore, we had also a contribution to our participants from the US, and we had just under 2,500 participants from America. Across Australia and southeastern Australia, we recruited participants in metropolitan regions, regional and rural areas. And as an example, just over 5,500 participants came from regional Victoria. For this phase of the study, which was the intervention phase, where our participants were taking aspirin or placebo once a day for the duration, lasted on average for 4.7 years of follow-up. So we commenced recruiting for the study in 2010. We completed recruitment of all our participants by the end of 2014. And on average, the people who completed the study mid-2017, there was a 4.7 years of follow-up. So some people had a longer duration in the study and some people had a shorter duration in the study. So 16,703 participants is a lot of participants. And in order to get those participants, there was a lot of background work. And so in order to get 16,000 people on board, we had to send over 500,000 letters of invitation to people who we had identified as being eligible for the study, that they were over 70 and basically in good health. Of those over 500,000 people, 587,000 letters sent out, just under 75,000 called us up and said, I'm interested in the study, tell me more. Of those, 13% went on to actually attend a study visit. So 20,000, we actually undertook 20,000 visits. We call them visit one. So we had 2 visits prior to randomization, and these were review of the participants, their eligibility, and some other criteria. We needed to confirm that these people were appropriate to join the study. And of the people who came to the first visit, 86% of those continued on for the second visit. So, and then finally, of those who undertook a second visit, 97% of those, and that's where we get our 16,703 participants, continued on with the study. And I guess I really wanted to demonstrate to you that it was no small feat to recruit this number of participants, and there's a lot of background work with big numbers to get down to our 16,000 participants. So this is just a brief schema to demonstrate the location of our participants. So we are based here in metropolitan Melbourne, and we had participants through our major regional hubs in Victoria: Geelong, Ballarat, Bendigo, Wodonga, Terrelbin, Warrnambool and Mildura, and all the surrounding areas as well. In addition, we had sites in Tasmania, 3 sites in Tasmania: Burnie, Hobart and Launceston. We had a site in Canberra, a site in Wollongong and a site in Adelaide. And so this was a nice way to do the study because we had a good representation, particularly over Victoria, of the entire population group. Many clinical trials of this size focus on recruiting participants in metropolitan regions, and that's purely due to logistics and the assessments undertaken. It's just easier to maintain it in a local region, but we had the opportunity to expand it wider, and which really made it an important outcome of this study, that it was the outcome could be ascribed to an entire population group, despite where you might live in regional or metropolitan areas. So when a participant joined our study, we undertook some annual assessments with our participants. And we looked at a range of health measures, and these included some clinical measurements. We coordinated to get some blood samples. We also looked at some physical measurements, things like a hand grip strength, blood pressure measurements, and a walking speed test. We also did a number of assessments on their cognitive, memory and thinking function. We looked at lifestyle, mood and quality of life assessments as well. So each of these assessments was performed once a year, and so over time we could track changes in these assessments. And in addition to these assessments, we also captured health events of interest. For the Aspirin study, we were looking at the health events that included myocardial infarction, heart failure, major bleeding events, stroke events, depression events, and dementia events, and permanent physical disability. So we examined all of these factors and ultimately wanted to see, was there a difference in our groups purely based on having taken aspirin or not. Here you can just see a schema of the breakdown of where our participants were derived from. So you can see we had an almost fairly equal distribution of participants from regional Victoria relative to metropolitan Melbourne. We had a really good representation in Tasmania of just over 2,000 participants. ACT had just under 1,000, South Australia 1,200, and almost comparable numbers in New South Wales as well, along with the almost 2,500 participants based in 32 sites across the US. As you can imagine, with all this data captured for just over 19,000 participants every year, it's a lot of information that we're capturing. And it's in this first portion of our intervention trial, it equated to just over 36 million individual data fields that are contained within the Aspirin data set. So there's a lot of information, a lot of data to review and collate together. So if you can imagine that getting this incredible resource of 19,114 participants was amazing, and we were funded to do some very specific questions and address them, but there was so much more that we wanted to examine and question, and we had the opportunity in this group to value add and to offer the opportunity for these participants to take on other aspects. We call them sub-studies, and things like looking at cancer, more closely looking at cancer outcomes. We had a questionnaire that was delivered in years 1, 3 and 5, looking at the Aspirin longitudinal study of older persons, which was examining many questions that we're really interested in but just didn't have time to examine in our annual visits. We looked at the role of sepsis and aspirin, the contribution of aspirin to age-related macular degeneration, so reduced function of eyesight. Importantly, we wanted to examine the potential role of aspirin in anemia. There's some good evidence that aspirin may have a positive effect on reducing depression. We looked at fractures, we looked at genomics, and one of our biggest sub-studies was called the Aspirin Healthy Aging Biobank. And in this study, we collected blood samples from just over 12,000 participants before they started taking the study medication, and then 3 years afterwards. So the biobank was unique in that it was capturing samples and people who started healthy, and then we could use those samples that happened 3 years later and compare them to the data we'd reviewed and, for example, demonstrate the people who may have had a stroke. Was there something in their blood that could have been predictive or protective against stroke? So this enabled us a wide opportunity to examine in more greater detail the development of disease and the contributing factors to that. We looked at some hearing studies, knee and some brain imaging studies, as well as one of the studies down here looking at a study of neurocognitive outcomes in sleep apnea. So we were able to provide our participants with a take-home sleep apnea device that they would test and then would send back to us, and to see the influence of aspirin potentially on preventing some of the negative outcomes of having sleep apnea. So after all that time, a comparison between aspirin and placebo groups after an average follow-up of 4.7 years, the final outcome of that intervention phase of this study was that a life free of physical or cognitive disability, that aspirin didn't have an influence on this outcome. It also, in terms of rates of cardiovascular disease, did not, there was no difference between the aspirin group and our placebo group. And unfortunately, what we did see is that there was an increased risk with aspirin of major bleeding events. So from this, we were able to really importantly identify that the risks of taking aspirin, low dose, for primary prevention outweighed the benefits in an older population group. And this was really important because when we started the study, half of the GPs who engaged with our participants felt that primary prevention by using aspirin, low dose aspirin, was really great and should happen for all older people. Yet half of our GPs felt that there were risks involved here. And so it was really important to demonstrate that taking a low dose aspirin across a general population of older people actually was not beneficial and may be harmful. So really important to know this information. So participants aren't taking it, or people in the community, and doctors aren't prescribing it unless they have a major need for it. So for primary prevention, low dose aspirin is not an effective tool in older people, but for secondary prevention, where someone's had a heart attack or a stroke, low dose aspirin remains a really important management tool for the prevention of further, for reducing the risk of further events in these populations. So you might say, well, if you've shown that nothing happened with aspirin and it actually hurt, what we do now? Well, what we have continued to do is maintain this cohort of participants. And while we started here in Australia with just over 16,000, we now have about 12,500 continuing on the follow-up phase of this study. And that's really an important and valuable outcome of this study. And it's on the basis of the high quality long-term follow-up of our participants that we can continue to do these assessments. And one of the key factors as to why the value we will continue with this study, even though the participants are no longer taking aspirin, is that there are some research indicates that the effect of aspirin itself on cancer may not appear until later on. So we only followed the effect of low-dose aspirin on 4.7 years, but there's indications that the benefits of aspirin for cancer reduction may take longer to develop or to demonstrate it. So Aspiri-XT is the extension phase of the Aspiri study. And with it, we aim to understand key factors that influence aging, both good health and disease development. And importantly, to also understand why some people, older people, become frail and not others. And so that's linked to resilience. And there's resilience can be linked to genes, like the genes that you have. It can be linked to emotional support and a state of mind. So there's some really important questions that still need to be addressed in this population group, and demonstrates why we're still continuing to follow on this cohort, despite the earlier studies demonstrating that aspirin itself was of no greater benefit and potential harm. So I'm actually complete my presentation there, and I think I'm pretty much on time, but I'm happy to have questions, and I might leave my contact details up there. So Mateus, if you'd like to follow up from this.
Yes, and thank you so much, Sharyn. I felt very inspired by your career. I could relate it with some of your experience as well, and it brought me some nice memories. And thanks for sharing it with us. And to kick off the Q&A session, I have a few questions for you.
Mm-hmm.
How important was your summer internship, your summer experience for your career?
Look, ultimately, a couple of things. It provided me the experience of understanding what research was about, and the fact that I liked it was really important. Equally, I could have found I didn't like it, and so I think these opportunities are really a great tool for you to know what you like and what you don't like. And for me personally, the fact that I liked it meant that I maintained this network, which has held me through my entire research career. So it was instrumental in where I went. My pathway would have probably been the same if I'd not done it. It might have just been in a different way. But I think these kinds of opportunities that come up, things like work experience during high school and these summer vacation scholarships, I think are really valuable, of both teaching you what you like and what you don't, and maintaining that network. So yeah, a really valuable tool if available.
Exactly, I totally agree. I also had the opportunity to do a summer internship and actually change my decision of what to do at college, going to university. So I totally agree with you that it can be a very good opportunity to get a more understanding of career options and what you'd like to do in the future.
That's right.
We receive a question in the chat. The results you received from your studies were what you expected? I guess it's more a general question instead of like a specific study.
Well, I guess that's the thing. I can probably end with the Aspirin study. So I guess number one, if you know the answer to your question, you shouldn't be doing the research. But we did, on the basis of what we knew about aspirin and its role in secondary prevention, apply that in a new philosophy to primary prevention, did actually believe that it would actually provide some benefit. So we actually demonstrated the exact opposite of that. But the important thing is we found an outcome, and that was what was the important part of the study, that not that we gave the answer that we thought we would find. If, finding that it provided benefit would have been very, very useful outcome, because then we could provide another tool for patients to take on for primary prevention. But, the finding that it was a negative study actually demonstrates and helps doctors prescribe with low-dose aspirin. And so is actually, whilst wasn't what we were expecting, was a really important finding of itself.
Exactly. In my experience, I had similar situations as well. Got some results in my PhD. It was not what I expected, but it helped me moving forward and trying to look for better answers in the next experiments.
Yeah.
Cool. Another question. You mentioned you moved fields slightly in your PhD. So how challenging was that, and what was your biggest learning from this change?
Look, it probably wasn't a big leap, so I don't think it was a super challenge that way. An honours year is a mini review of what a PhD is about. So I think the PhD is the challenge itself, despite the field of research you might be doing it in, about problem solving. And I would suggest that probably the biggest skill you get from these research programs is problem solving. And I still use that every day, and just identifying, knowing what a problem is, and if not knowing the answer, knowing how to find an answer, looking around, other options, exploring options. So I guess the biggest challenge is having faith in myself, and for research program, not as much as what I'm doing now, but early on, publications and meetings and those things are really important to focus on building your research career. So taking the time to do that, the demands of your time, you've got to do the research, you've got to write a thesis, but you also have to go to scientific presentations and you have to write the publication. So doing all of that at one time, I guess, is probably the challenge.
Yeah, exactly. I actually finished my PhD in 9 months ago, and I know exactly what you mean about doing all those steps to get to the end.
That's right.
Yeah. Another question, if you had to choose, what was the most interesting clinical trial that you worked on and why?
Probably what I'm doing currently now. And I guess so many reasons, but one of them is the factors contributing to healthy aging. That's as where we're all heading. But it's also been meeting our trial participants, and the biggest thing I've learned is probably a segue, not directly from the clinical research, but about it's about a mindset about healthy aging, and that if someone has a passion for life, whatever that is, that I think you can maintain good health, and that can be gardening, it can be salsa dancing, it can be fishing. We have these incredible participants that do amazing things, and it's because there's something that enables them to wake up in the morning and get going and do something. So I think that's been really the nice part for me. And I really value the clinical research side of things now, that it's a direct application, if not me, to my family, to my colleagues, those kinds of things.
Yeah, I really appreciate how it's easy to see the application from your study in our daily lives. It's very inspiring. And the last question, what do you want to have told to your high school self?
Well, what would I tell my high school self?
Yes.
That's a really good question. Have faith in yourself and seek every opportunity. Things, I guess little segues, things I didn't talk about early on during my early return to Australia and things like that. I took up media opportunities. I did some school series through this program as well, went out to schools, engaged with them and talked about career development, spoke on radio, spoke on TV. And I think that continued to help me in my current role now, where I have done that as well during our recruitment phase. So I think my big thing is seize opportunities and make the most of them. You just don't know where they'll help you. And, it might not be what you're particularly interested in, but there's value in learning these things. And, public speaking is a really scary experience for many people, and I still sometimes have concerns, but I think take it and run with it. And again, my demonstration, that work experience, that summer vacation scholarship helped me in ways I didn't know at the time were going to help me. And so look for opportunities and try them, even if you don't think you're going to like them. And it's called transferable skills is the other thing, that you just never know what you're doing may benefit you, if not now, in something else you're doing.
Thank you, Sharyn. Yeah, that's a very good advice. I'd like to thank you, everyone, to join us today, and especially Sharyn for sharing her journey with us. We appreciate it. And this series of talks was supported by the Victorian Challenge and Enrichment Series. The Shape of Future series will be continued all this year, so you can tune to hear from many more scientists in the upcoming months. All the information, it is on the STELR and the ATSI websites. Thank you for joining.